For this section, we're going to start looking at graphing quadratic functions. And a quadratic equation is where f of x, and remember that's what we called y, equals ax squared plus bx plus c, and where a cannot equal 0. So the a, the b, and the c, those are actual numbers, and then the x's are obviously our variables. And the shape of this graph is considered a parabola. And a parabola is what's pictured right here. And parabolas are symmetric about a central line called our axis of symmetry. And I'm actually just going to underline in blue to show the graph. And then the axis of symmetry is what's drawn in red. And the axis of symmetry splits the graph so that both sides of the graph are equal. So they're all like this side can be folded onto this side. And the axis of symmetry intersects a parabola at one point, and this one point is called our vertex. And so a vertex is this point that's right here. So this is our vertex, and the red line is our axis of symmetry. So for this example, we're going to graph a parabola, and we're going to use a table to help me graph y equals x squared. So let's draw our table. And if I have x and y, and I'm just going to choose some random points, so we're going to choose -1, 0, 1, 2, and -2. And the first thing that I'm going to have is if I put -1 squared, so -1 times -1, that's 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And -2 is squared is 4. So let's go ahead and graph these points. So -1, 1. I want my points to look pretty good on the graphs. And then I'm going to have 0, 0, and I'm going to get 1, 1. And then I have 2, 4, -2, 4. And even if I did 3 and -3, 3 would be 9, and -3 would give me 9. And so then I can go 3 to 9, and -3 to 9. And my axis of symmetry is what's going to split my graph in half. So the axis of symmetry is what is going to make my graph in half, and that's actually right here because it splits down that vertex. And so I'm going to get that axis of symmetry is at x equals 0. I also need to connect my graph, which I forgot to do, so we're going to connect it as a parabola. And you can see a relationship between the points, that these points are equidistant from each other in the axis of symmetry. So all my points are equidistant from my axis of symmetry. And if you notice a relationship, I went over 1, up 1 from that vertex, and then from that point I went over 1, up 3. And then from this point, I went over 1, up 5. And I did the same thing on this other side. So my parabola really has an axis of symmetry. Go ahead and pause the video, and I want you to try this one on your own. And use a table to help us graph this. So if I have my table of x and y, I'm just going to choose some points. So we'll do -2, -1, 0, 1, and 2. So -2 squared is 4, and then -4 gives me 0, and -1 squared is 1, -4 gives me -3, 0 would give me -4, 1 squared -4 would give me -3, 2 squared -4 still gives me 0, and if I did -3 and 3 just so I have some extra points, I'm going to get that 9 minus 4 is 5 for both of those. So let's go ahead and graph this. I'm going to have negative 2, 0, negative 1, negative 3, 0, negative 4, and then I'm going to get 1, negative 3, 2, 0, and then I'll have negative 3, 5, and that point should actually be right here, and then my other point, it will be 3, 5. So my parabola is there, and my vertex now became negative 4. So right here is my vertex, and my axis of symmetry is still my line that cuts it in half. So the axis of symmetry is x equals 0 still, with my vertex being 0, negative 4. And as you notice, my minimum point is this negative 4, that the graph doesn't go anything lower than negative 4. So I have a minimum point here, which means that my range has to be that y is greater than or equal to negative 4. And my domain is just going to be all real numbers. So my range is what my is based off of my minimum point, or if the parabola was flipped upside down, then it would be based off of my highest point. So to find the maximum and minimum values, and we're going to state the domain and range, and we're going to use the following function. So the first thing that I notice is that this is going to be a negative, that a is negative. And if a is negative, I am automatically going to have a parabola that goes down because I know that a is negative. So when the parabola goes down, I have a maximum point. So a downward parabola has a maximum vertex. And an upward parabola has a minimum vertex. So let's go ahead and apply this to what we already have. So if I have the function y equals negative 2x squared minus 4x plus 6, I'm going to find what that maximum value is. And the way that I can do that is I first need to find that vertex. And so to find the vertex, I'm going to use the formula negative b over 2a. So b is already negative 4, so I have negative, and I'm just going to substitute in that negative 4 over 2 times, and a is negative 2. So I'm going to get that I have 4 over negative 4, which equals negative 1. So x is going to equal negative 1. So now that I know that that vertex is negative 1, and all we did was we found the x coordinate, I'm going to need to find the y coordinate. So if I already have x, I can go ahead and substitute this in for each one of my x's. So f of negative 1 equals negative 2 times negative 1 squared minus 4 times negative 1 plus 6. And so f of negative 1 equals 8. So the maximum value is 8 because my vertex now is negative 1, 8. So So the domain is still going to be all reals. And my range is where y is less than or equal to 8. And the reason I have that y equals less than or equal to 8 is because I know that a is negative, so it's going to have a maximum, so it's down. And my y of my vertex is 8, so my y here would be 8. And I want anything that's less than 8. Go ahead and pause the video, and I want you to try this one on your own. So I see that a is positive, so I'm going to have a minimum. So I need to find my x-coordinate of the vertex, so the x of the vertex. And to do that, I'm going to use negative b over 2a. So I'm going to get negative 4 over 2 over 2, which gives me 4 over 4, which equals 1. So now to find the y, I'm just going to say that f of 1 equals 2 times 1 squared minus 4 times 1 minus 1. So I'm going to get 2 minus 4 minus 1, which is going to simplify to negative 3. So f of 1 equals negative 3. And so my domain is all real numbers. And my range, because I have a minimum, I'm going to have that y needs to be greater than or equal to negative 3.